Hi everyone. All right, so we're kind of starting a little off of where we are in the packet. So we should be on page 13. We're going to talk about a couple of these things and try to get back on track here. Okay, so find the x and y intercepts from a table. We talked about how to find the y-intercept, but we didn't really talk about the x. For you guys, a lot of the time, the x-intercept you should be able to see it either in the table or it should be relatively clear from solving. So I'm going to show you what I mean by that. So your x and y intercept, your x-intercept, you have x is some number and y is 0. Your y-intercept, 0 is x, and then y is some number. So in our table, this makes it pretty easy because we look for zeros, and it happens to be 0, 0 for both x and y. So this function crosses when x is 0, y is also 0. And then when y is 0, x is also 0. So what I mean by this statement, it should be pretty obvious. It should be something like that. You'll learn how to find the x-intercept using logarithms in Algebra 2 or Pre-Calc. So for 2, is the table an example of growth or decay? So we're going to take a look at our table. We did talk about how to do this, but I want to make sure that we're good. So if we're looking at our y values and our x values are moving by 1 unit, so that's good. But our x values are changing and they're actually decreasing. So you can say that it's decay. And then remember to find the decay, to find what that would be, the base, you would take your y value divided by your previous and get a number. So here we are multiplying 2, 0.6, 0.18, 0.054 by 0.3. So our base here would be that 0.3 to 3/10. If you recall, our general form of an exponential function looks like this. Y equals a times b to the x, where a is your initial value or your starting point, and then b is your exponential base. Okay. So whenever we have an exponential function, that's what we're looking at. And a helpful fact here is that your initial value is actually going to be your y-intercept. Okay. So fun fact, make sure you have that written down. So then we have, therefore, if we have a y-intercept or initial value, then the rate, then we can write the equation for these functions. Okay, so kind of doing a little bit more than what we just did the other day. So for 3, we have this table. What is the y-intercept? What is b? And we're going to write our equation. So here, according to what a y-intercept is and according to our table, wherever x is 0, that is our y-intercept. So here, our y-intercept is 0, 1. Our b, to go from y value to y value, we need to figure out what we're multiplying by. So to get from 1 to 2, we'd multiply by 2. To get from 2 to 4, we'd multiply by 2. 4 to 8, multiply by 2. And 8 to 16, we'd multiply by 2. And we can confirm this by also doing 8 divided by 4, 4 divided by 2, and so on. So here our base, exponential base, is going to be 2. So to write our function, so remember y is also f of x, so f of x equals our initial value, which here is 1, times 2 to the x. So we really have f of x equals 2 to the x. Okay. So looking at number 4, same idea. If we have a y-intercept or initial value and we can find the rate, we can find the equation. So we're going to do that exact same thing. So our y-intercept here, wherever x is 0, we have 0 and 0.5. Our y-intercept here is 0 and 0.5. And then to find our exponential base, we find the change between our y values, in this case g of x. So to get from 1 to 0.5, Well, anything times 1 is just itself. So here you could say, well, if I multiply by 0.5, then I would get 0.5. So to check that, you can also take 0.25 divided by 0.5 or 0.125 and divided by 0.25, all of which should give you 0.5. So here our base is going to be 0.5 or 1/2. So here g of x is our starting point, or not starting point, g of x is our y. Our starting point here is 0.5, that was our y-intercept or initial value. Remember, that's your a, okay? And then my base here is either going to be 0.5 as a decimal, or you can write 1/2 and raise it to the x. So you can have either of these, 0.5 times 0.5 x. Either of them are fine. Okay, so a lot of this you already knew, but again, we're looking at it in a different way, so I want to make sure we just discuss it. So moving on to the next page, we have 5 and 6, which is the same idea. So I want you to try 5 and 6 on your own. Okay, so take a look at your table, find your y-intercept, find your exponential base, and then write your equation. Okay, so go ahead and do that now. All right, so for 5, your y-intercept from your table is 0. Your base is 3, so to get from 2 to 6, 6 to 18, 18 to 54, again, you can do the division thing like we have talked about and just confirm, because that's exactly the process. And then to write your equation, you have your initial value of 2 and then 3 to the x. I wrote it 2 different ways, with and without parentheses. So I want you to go ahead and continue and get number 6 done. So go ahead and do that now. All right, so you have a y-intercept of 0.32, it's where x is 0. B, your exponential base is 4, and then there is your equation. So let me know if you have any questions on how to do that from your tables. We are going to do one more problem together, and then we are done. Okay, so we have our rabbit population growth. So in 1995, there were 85 rabbits in Central Park. The population increased by 12% each year. How many rabbits were in Central Park in 2005? So first things first, okay, I know there's different parts. We have a table, we're writing the function, we're going to make a graph, and we're going to do the y-intercept. So there's a few things that we need to identify before we begin, just to make sure that we're all on the same page. Okay, so first and foremost, is this growth or decay? So this says population increase, which means you have growth, okay? And then the rate of growth, so this is your growth rate, is 12%, okay? And then the other thing that we're missing is our initial value. Here, 85 is your A, or your initial value, okay? Which also means that it's your y-intercept. Okay, so your initial value, remember, is also your y-intercept, so keep that in mind. So when it's not on your table, you need to take a look at what you're given. So for part A, it says complete your chart, and your x value or independent variable is your year, so it's your time. And then your number of rabbits, that's your f of x or y. Okay, so make sure you are able to identify those. So if we're looking, we need to fill in this table, and based off what we talked about, we need our exponential base. Exponential base, I'm going to abbreviate for space. To get that, we would take 100, add it to 12, and we get 112%, which means our B is actually equal to 1.12. Okay? So even without this chart, we can do parts of this problem. And I'm going to kind of skip the chart for a second, because this is going to help us using what we know. So A is the chart, B is writing your function, and then C we're graphing, and then using part D to write a conclusion. So for part B, it says write your function. Well, that's just writing what we think our equation is. Well, even without this part, we can still write our equation. So our equation here has our A, which is 85, and our B, which is the growth rate plus 100%, our exponential base, which is 1.12. So now we can use this to help us find the rest of the chart. Okay, so sometimes you need to do different parts earlier, so make sure you're reading your entire problem before you start. So it says when year 1 passes, we have 95 rabbits. So year 1 is with 1996. Year 2 is with 97, 3 with 98, 4 with 99, and so on. Okay, so the x values we're going to plug in are these year 1, 2, 3, 4, 5, and 6. Okay, so I want you to go ahead and get the numbers for your chart. Again, remember you are using the 1, 2, and so on. We're not using the 2000s and 2005s and things like that. So go ahead and fill in your chart. All right, so I want to talk about the numbers in the chart really quick. So when you plug in 1 for x, you do get 95.2, but they only wrote 95. So remember, because you have a rabbit, just like a human or something like that, like in any other animal, you can't have 0.2 of something that's living. So you round down to the nearest one you have. So even if it's this one with year 2 where it's 106.6, you're not going to round up to 107 because you only have 106. Where is the other part of the rabbit coming from? So we're going to round down to 106. So same thing with year 3. We get 119.4. Again, we can't round up. We need to round down because we can't have 0.4 of an animal. So you're going to do that for all of these, okay? Because you can't have parts of an animal. I mean, you can, but they're not counted as living beings. It's still considered, an animal. So you're going to round to the nearest whole number you have. Okay, so take a minute, check your numbers. If you need to pause. I'm going to continue. So for C, we need to graph. Okay, so the numbers in our chart we are going to graph. We are going to graph the ones that we wrote, the numbers we have. So we need to make our graph. Okay, so that's a big undertaking. So if you remember, our x value is our time. So this is going to represent the years since 1995 because we're looking at number of years. 0 will be 0, okay? And then I'm going to try to space these out just a little bit. So I'm going to go every other. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 will be my last one, okay? So now we also need to do our y values, and if you remember from your chart, that's your number of rabbits. Okay, so your number of rabbits. So when we look at our number of rabbits, we're starting at 85, that's our y-intercept, but we need to get all the way to 263, okay? So when we do that, we need to kind of scale. So I know if I go every other, I can fit 10 numbers, and this one looks a little bit longer, so I could probably fit more. So I'm going to go, every line is 15. So every other line is going to be 30. So 1, 2, 30. Another 2 lines, I have 60, 90, then I have 120, 150, 180, I've got 210, and 240. Okay, so it looks like it'll fit nicely. So now I just need to get started. So remember your y-intercept is at 85, so you're gonna have to approximate that just a little bit. So it's every 15, remember? So this is 75. So right around in here should be our y-intercept. And then 1 was 95. So again, it's gonna be approximate. It's not gonna be perfect, but it needs to be close. So you're showing me you know how to graph. So then year 2, okay, year 2 was 106. So 2, and because that's 15, it's going to be around here. That's 105-ish, so 106. Year 3 was 119, so that's going to be really close to 120. 4 was at 149, so really close to 150. 5 we had, oh no, I skipped one, I'm sorry. We have, sorry, so 4 was 133. That's my fault. So right in here. 5 was 149. Okay, so that can go back where it was. 6 we said was 167. We're going to just continue this process. So make sure that you're trying to get everything as close as you can. Remember, we went by 15s. Okay, so 15, 30, 45, 60, 75, and so on. Okay, so make sure you're understanding we went by 15s. So then year 7 was 187. Okay, so we're looking at in here. 8 would be 210, so that's right on a grid line, which is kind of nice. And then 9 was 235, so it's closer to 240. Oh, we need to go a little bit higher. I didn't graph enough of them apparently, so we need to go one more to 270. And so this one will be 263. That's a little high. And that one's a little high. Sorry, I'm fixing my graphs. So 235 is below 240. It's right down here. And then 263 is right over here. Okay, and so this is an exponential equation, so it's going to curve a little bit, and then we are going to put our arrow at the end because the years don't stop. Okay, so it should look something like that. It's not going to be a straight line. It should curve in some way. It's not super curvy, but make sure that you have some curve to it to show that you understand that it is an exponential function and not a linear, because linear would just be straight. Okay, you would have a straight line, but we need a curve. Okay, even if it's a slight curve. So then D, what is the y-intercept and what does it represent? So we found that already. We said 0, 85 was our y-intercept, and this represents the initial population of the rabbits was 85. Okay, so that's what it represents. It's your initial value. It's where it all started. So you started with a population of 85. So that's the sentence you write. Okay, let me know if you have any questions. Other than that, have a great day.